Hello everyone and welcome to another video. Today we'll be exploring transformations of functions. This topic will be divided into two videos as it is a very broad topic that we have to understand deeply. Transformations of functions allow us to change the position, size, or orientation of a graph without altering its fundamental shape. They help us understand how equations control the behaviors of graphs and make it easier to model real-world scenarios. By applying transformations, we can shift graphs up, down, left, or right, stretch or compress them, and even reflect them over an axis, which would be the x-axis or the y-axis. Today, we'll break down how these transformations step by step so you can see how each component of a function affects its graph. The general format for transformations of functions is the following. F of x, or y, you can call this whatever you'd like, is equal to minus a, f of minus b, x minus h, plus minus k. Let's break down this general format into different parts. To start off, this negative sign right here, if it is present, means that the function is reflected on the x-axis. If it is not, the function remains the same. This a value determines the horizontal stretch or vertical compression. If a is bigger than 1, then the graph stretches vertically, which makes it taller. If a is smaller and bigger than 0, then the graph compresses vertically, making it shorter. And if a is smaller than 0, then it is like when it is a negative, it just reflects on the x-axis. The f we see here is simply to define our function. This negative sign over here is similar to this negative sign over here. It represents a reflection. However, the first negative sign represents a reflection on the x-axis, and this one represents a reflection on the y-axis. This b represents our horizontal stretch or compression. If b is greater than 1, the graph compresses horizontally, making it narrower. It is narrow. If b is smaller than 1, but greater than 0, the graph stretches horizontally, making it wider. And if b is smaller than 0, then it is what we have here, which would be a negative. The graph reflects on the y-axis. Our x here is just our x-coordinate, so our function based on x. This h represents our horizontal shift. If h is bigger than 0, then the graph shifts to the right h units. If our h is smaller than 0, then our graph shifts without altering its shape, just moving one side or the other, shifts to the left h absolute value, units. Because this would be a negative number, so we must do absolute value to move it to the left, those units. And finally, this k right here refers to the vertical shift. It is positive and negative because it can be both. If k is greater than 0, then the graph shifts up k units. If k is smaller than 0, then the graph shifts down k, absolute value, of course, if it were a negative value, units. Let's apply what we have learned into an example. Imagine we have a function and we want to transform it. So, we move it -2 f of 8 x plus 2 minus 3. What would all of this mean? Well, first of all, the graph would be reflected on our x-axis. It would be vertically stretched, making it taller by 2. That would be our factor. It would be horizontally stretched, making it narrower by 8, a factor of 8. Then, this is a bit tricky here, as since the format is negative, this isn't really a positive 2, this is a negative 2. So, our graph would shift to the left 2 units. And finally, our graph would shift down 3 units, as it's a -3. Let's practice with another example. 1/2 f of -2 x minus 4 plus 7. In this case, we have no negative here, so the function does not reflect on the x-axis. However, it is vertically stretched, and since a is between 0 and 1, it is bigger than 0 but smaller than 1, the graph compresses vertically, making it shorter due to this. Here, we can see that we have a negative, so our function is reflected on the y-axis. Also, we have a horizontal stretch, this is our b, meaning that the graph compresses horizontally, making it narrower, as it is bigger than 1. Here, we see that our function shifts to the right by 4 units, and finally that it shifts up 7 units. Thanks for watching. In the next video, we'll dive into some examples of these transformations, applying them step by step to graphs so you can see how they work in action.